So for lesson 2, you'll be using a simulation. It's in your notes packet, so if you're absent, you can still do it. But essentially, you're going to work on 2 different parts, answering some main questions about limiting reactants and trying to essentially figure out how this is related to what we were doing yesterday. And hopefully, you'll see the connection to what we're going to talk about in a minute here. After that, we're going to do lesson 3 in the notes today, and we're going to discuss limiting reagents more. So limiting reagents are essentially the reactant or substance which is totally consumed during a chemical reaction. This will limit the amount of product that will be formed because it's going to run out, but it's not necessarily going to be the reactant present in the smallest amount. You're going to have to do some calculations to figure out which one is the limiting reagent. So you're going to first calculate the amount in moles of product formed for each reactant, and then you're going to figure out the smaller one is essentially going to be the one that's going to be the limiting reagent. So this first example problem here, we're going to try to work through this one together, see if we can figure this out. So we know that we have 37 grams of aluminum sulfate reacting with barium nitrate. We want to know the limiting reagent. Alright, so first thing we need to do with all of these is we need to balance the reaction. So right now the reaction is not balanced. We know that because we've got 2 aluminums on the left, 1 on the right, and you've got 3 sulfates on the left and 1 on the right. Okay, so we're going to have to add some numbers here. So essentially the reaction is going to end up looking like this when you balance it. So we have Al Alright, so we've got 2 Al and 3 plus 3 BaSO4. So first thing we need to do is figure out the reactants, or the amount of products that form for each of the reactants. So we know we have 37 grams, so we'll just kind of work through each one of them. So 37 grams, and that's of aluminum sulfate. Okay. Now, we're going to need to get from grams to moles because we can't compare anything unless we're in moles. So you're going to find the molar mass of this, which is 342. And that's in 1 mole. Okay, now we're interested in figuring out product. Generally you could pick either one, but it says how many moles of aluminum nitrate can form, so we're going to want to essentially just pick aluminum nitrate. So if we look back up here like we did before, there's a 1 in front of the aluminum sulfate, so we write 1 mole. Then there's a 2 in front of the aluminum nitrate, which is what we're interested in. So 2 moles of aluminum nitrate is going to go there. Okay? So you're going to go ahead and calculate that out. You're going to get 0.2162 moles of AlNO3. Okay, so aluminum nitrate. We're going to do the same process for the other reactant. So we have 52 grams of BaNO3, which is barium nitrate. Same thing, we need the molar mass to go here so we can get to moles, so 261.33. Now that's the number of grams that are in a mole by definition for the molar mass. Okay. Now, we need to convert from one product, or from one thing to the other. So again, the way that we do that is we need to use the ratio up here. So we've got a 3 in front of barium nitrate and a 2 in front of aluminum nitrate. So 3 is going to go on the bottom. Okay, so when you go ahead and calculate that out, you're going to get 0.133 moles of aluminum nitrate. So essentially what we're doing is we're just doing double of the work essentially for the problems that we were working on before. You just have to do the conversion for each of the 2 reactants. Once you figure out the number of moles of the product that you're looking for, the one that's smaller is going to tell you which one's the limiting reagent. So 0.133 is smaller, so this one right here. So that tells us that what we started with here, the barium nitrate, is going to be the limiting reagent. So the limiting reagent, I'm just going to abbreviate that as LR. Notice that this was the one that was present in a higher amount, so 52 is larger than 37, but once you do these calculations, you're going to get a smaller number. So now we found the limiting reagent. Now we need to know how many moles of aluminum nitrate can form. Well, we just did that. So that would be the 0.133 moles would be the one that can form. Next thing we need to do is figure out how many excess reagent is left over. The easiest way I think to do this is to kind of figure out how much you have left. So if we look here, technically we could have formed 0.2162 moles if we had this much of aluminum sulfate and if we weren't limited by this. So if we take that 0.2162 moles, that was kind of like what we could have made. We're going to subtract from that what we actually can make. So we can make 0.133 moles to figure out how much we essentially have left over. We're going to divide that by what we thought we could originally make. This is going to essentially give us like a fraction of what we could have made that would tell us how much is left over, because we're subtracting out how much we could make. So once we subtract this out, we're going to get the leftover amount divided by here, so we almost get a ratio of what's left over to what we could have made in theory. If we multiply that by what we started with here, the 37 grams, we're going to go ahead and figure out how much is left over. So when you multiply that out, it's going to be 14.24 grams, and then that's of aluminum sulfate. Okay. There's two ways of doing this part of the calculations here. Either you can work on a whole other bridge going backwards, or you can kind of use this ratio idea. Alright, so there's another example that's very similar, but you're going to want to go ahead and try numbers 1 and 2 in lesson 3, and let me know if you have any questions.